Okay, so this is an unprepared lightning talk, like just on the spot preparation. It's not going to go deep. So the topic is kind of like divided into three. One is tidbits, just cool small stuff which I learned over like past 3-4 months, and I'll talk about a FaaS server implementation, function as a service, and also a pet project which I had called Yet Another Expense Splitter, and how I approach it and my learnings on it. Right, so I'll get started with probably the tidbits. So what I have here is a very small example of this tidbit. One which I wanted to talk about was the init function. I'm not sure how many of you have used GOM or something like a database interaction library. So GOM is a ORM. It provides SQL. I'll show GOM in. So GOM has a dialect called Postgres, which internally uses libpq, which has connection object. So first, I'll just run the program. Probably things would be clear. So before that, I wanted to know, what do you think is the output of this program, like on your left-hand side? I'll increase the font. Sorry. Program on the left. What would be the output? Hello. Okay. Yeah. Okay. It is. But why? So what just happened over here was, hey, I thought every execution starts from main, but that's not always the case. What happens is Go actually runs the init function before any function gets run, any program gets executed. It looks through all the init functions in your source code. It runs that, does the init part of an init execution, and then runs the main. So that's why we got hello world. Note here, I've not linked the sample main file. So I have two main.gos. One is the root main go, and the other is the sample main go. I've not linked them, but there's one strange comment over here. Oh yeah, before that, so GOM uses init internally to actually wire up Postgres. So libpq does that. So it has an init function. You'd think that, hey, importing something like this shouldn't make any difference, right? Because it's not being used. So if I search for Postgres, it's being used only once. This is actually just a connection string. I just pass in that, hey, I'm using the database Postgres, and this is my connection string. But over here, what I'm doing is I'm just importing the dialects Postgres, which is being unused, like as the underscore indicates. So it has basically no function other than running this init code. That's all it does. That's why I'm importing. So a lot of places you'd be doing something like this, like the dialects Postgres internally does that. Yeah, there's a lot of lag actually. So apart from this, okay. So the second thing which I wanted to talk about, the small tidbit which I wanted to share, was the Go generate part, the Go generate comments. So I'm not sure again how many of you are aware of it. So Go provides you this generate command, which uses magic comments. So what's happening really over here is I'm running. So whatever, so this is just a small magic comment which I've added to the top of my file. It just says, hey, go colon generate and whatever command I want to run. This can be anything. Any CLI program which I have, I can run on it. So go run sample main.go basically is executing this main, but I might as well have typed something completely random. It does that as well. Like any command line tool is useful, it can run it. So why would I use something like go generate, right? So you have something like this package called static. So static embeds files into a Go executable when you have. So if you have attended Golang, probably if you have seen Wagner's lightning talk, you would have talked about static. So all it does is embeds static files into your Go program. So having something like this running, like you have the main make build commands. Instead of that, you could have Go generate, and that can do all your building for you. And then you can pretty much. So oh yeah, I could do this as well. This would be interesting. So I do Go generate to actually build the sample main dot Go. It did in my root directory. So I can compile other Go files which are not particularly imported in my program and then compile them as part of a generate command. So those are the two small tidbits which I have to share. Um,
Does it execute the program, rest of the program?
no, it does not. So Go generate only runs the generate commands.
So you don't need to have a valid program, that just goes.
Actually, I'm not sure. Let's try that. So what if my program has a compiler error or something? Oh yeah, I don't need it.
You don't need any of those.
No.
So it's just a ASCII file with a lot of code generated command.
Yeah, you can have that. And yeah.
Basically shell script.
Oh yeah, you can. The, yes. So it's pretty much like shell script, like running a shell script, but
Maybe there's a specific use case that I'm not able to where you want to do something before you actually execute the program, which is main purposeful for the program.
Environment setup.
Yeah, probably environment.
environment setup is one thing.
Okay, what that static? What is that? I didn't get that.
Oh, static embeds. So you have your JavaScript and CSS and all that. Like let's say you're writing a web app in Go for some reason.
Your static content.
Yes.
Just put it in the binary.
Yeah, it actually compiles it as part of a binary. It adds a binary file into your Go code. So you don't import. You're not serving other static content from file system. Rather, you're
So I can actually go to the Go binary and get this static content using some certain set of commands. How do I get if I put a web directory inside the static?
right.
How will I get it? Because this is like I can compile my entire website, put it inside a Go binary, and just move that one binary. I don't have to worry about any other assets.
Totally, you can.
But how does the server? How will the server serve from the binary?
It's base 64 encoding.
So you'll be writing a web app. So that web app use some framework or whatever. Like I just have many frameworks. So we use that to to have so related FaaS and way to serve static.
So the framework knows where to pick up the files,
It's a
and
framework.
it doesn't need to, and it doesn't necessarily need to be on the file system. It can go from inside the binary. It's very good actually.
Actually, what it does is when you're not using the static library, what you do is you grab a OS dot file, OS dot open file
Yeah.
to open an HTML file. That's what app wants. Static. But
So it's an object ready to access. Like you don't open and close the file. You don't have to go through the directory, the disk. You don't have that disk latency. You are serving from memory all the time.
So since the binary is not part of the program, you will just
That's pretty good actually. You don't have to read the file system. I don't have to worry about assets in a different folder. I can compile all assets in the binary. Now, how does, for example, if I have an Nginx in front of this website, how will it direct, for example, requests, for example, .html requests, to direct it to this website?
So if you look at that, it does say that, hey, you have to define where exactly you want to serve it from. So you're saying that,
adding a handler.
yeah, you're adding a handler called /public. I'll be serving the files from the static FS.
Okay, so if I get a request to the public route, then it will pick up from the
It will
public folder.
strip that public out, and whatever file is there, it would route that request onto the static file server. Right. So that was the tidbit part. I'll just close this. Okay. Right. Before I go into this, I would first like to talk about my pet project. It's called Yes. So yet another expense splitter. It's actually available on GitHub. It's slow today. I think it's my laptop. It is. I have to upgrade. So So it's a simple web server, like an API server, written using Mux, Gorilla Mux, and I'm using middleware called Negroni. I've written some tests also. I think just one test case, but yeah. So the idea of this app was to get familiar with Golang. This was written sometime in December. I haven't written the front end yet. It's still a work in progress, but probably I'm going to write it in Flutter. Like I'm going to do a web app in Flutter. Mobile apps in Flutter. Yeah, exactly. I'm using this as like a code zoo kind of thing. All right. So yeah, as soon as it opens, yeah. So this pretty much uses a simple JWT token authentication. Again, I wouldn't recommend anyone to use JWT alone on production, but beside the point, it was something which I wanted to try. So one, so some learnings with Golang, where so coming from Rails was that I couldn't understand how to structure my project for one.
Rails does everything for you.
Rails does everything for you. You don't have to think. You just have to go open the file, write content, and that's it. And that's actually there with a lot of other languages. With Go, the problem was importing other files in your project. It's not straightforward. It's not trivial. Like you can have everything in the same namespace, but then in the same package. But then there's no point in doing that, right? Like code segregation. So one thing which I wanted to do was partition all the files across multiple packages. So I had come up with this structure. Probably this is to validate if people are doing the same way. So I had API. I had split my files across layers of the app. So DB sits in its own package. Models sits in their own package. Not this one. Models sit in their own package. So I'm using GOM particularly. I really like GOM, the way it does things. So GOM is one of those variants. A lot of people prefer SQLX. I like GOM because with this structure, I can define my entire database. Whatever changes, like if I have to define new fields and I have to run, like I don't have to write explicit migrations. With GOM, I can pretty much add the field over here and get it running. Like let's say if I add email. I think it's still building. Okay. Oh, there was some other server running on that board. Silly me. Awesome. Okay. So awesome. Okay. So email got added. If you look here. So with GOM, the thing was I just added a field email and to the struct, and it basically syncs up with the database to add that email field onto my table. So with GOM, that's the thing. That's why I pretty much like GOM. I don't really.
Handle migration.
Yeah, it does. It does auto migration. So for GOM, the thing was this is all I'm doing. So I'm saying, hey, for this instance, auto migrate on this structure, auto migrate on this structure, auto migrate on this structure, and add these constraints. So it does not do constraints really well. So you have to really add the other constraints which you need. That's pretty much it. So I had just two constraints, one on mobile number and the other was on username. So that's added. I haven't set up my Postman, so I'm probably not gonna test the API. I'm not going to show the API on your Drive, but yeah, it's deployed on Heroku. I'll probably upload the documentation today or something. Anyway, so yeah, it pretty much uses standard Go stuff like structures and so the only thing which is unfamiliar or probably something new for me was JWT in this project. So JWT tokens are something which have come up recently as an alternative to doing session stores like your cookies. So a lot of people have started using JWT because it provides the like using a JWT token, you can access both. You just pass in this JWT token which is generated. So I'll just show what a JWT token looks like for those unfamiliar. It's usually not this slow. Time now. Like it's really not this slow usually. Okay, awesome. Find the app. Still not loaded completely. Okay, awesome. So this is what a JWT, on your left hand side, the encoded part is what a JWT token looks like. So you have the algorithm defined, you have your payload, which is the data which you'd be sending to the client side instead of your cookie. So once a user logs in, basically, once a user tries to create a session, you'd be generating this JWT token and sending them across the across over the wire. And it also contains a secret. So thing is, decoding a encoded JWT token is easy. You don't really need this verification signature. But what verification signature does is it provides a confidence to the client that, hey, this token was generated from the server only. It wasn't generated from some other. So basically, the secret will be shared between the client and the server.
But obviously, they also advise that you're not supposed to put anything secret in the structure, data structure.
You're not supposed to put passwords or anything because over the wire also it can be decoded.
It can be seen.
Yeah.
The signature is only to verify the authenticity of the.
It's kind of like saying that, hey, this is the server which generated this this JWT token, not someone else in the middle. It just tries to avoid the man in the middle attack, but there's no privacy on JWT token. Data is completely naked. So that's on JWT. On the API side, probably I'll open. Okay, so this was the interesting part for me on the API side, or thing which I was struggling with the most was handling middleware. So you have the router. I have this users get. So just it lists all the users which are there on the server apart from the current user. So I use the get users handler, which is defined inside my users.go. Apologies for so much code. So all it does is it gets the request context, the logged in user itself, and it basically finds all the users which are there in the database apart from this current user ID and sends it back. So it's pretty straightforward. But handling the authentication, making sure that the user is logged in was pain because it was using JWT. So JWT provides its own middleware, the library which is there in Go. So using that it became straightforward. But thing was, I did not want to go through the cycle of taking the token and then mapping it to a user each time for each request for each of my endpoints. One way was to add a middleware. Adding a middleware was simple with Mux and Negroni. So I'm using Negroni as a middleware handler. So I get the JWT token from the user, from the request context. I get the model find user from token. So yeah, so this is defined inside my user models. In my package model user.go. So I just pass in the JWT token and the database instance, and I say, hey, I have this user ID. Now check if this user ID actually exists in the database or not, and return me that user ID. If I get an error, I basically unauthorize or I create a new request object with the same context and adding the logged in user into the request context and pass it along. So that's one way which I've done. I've approached it. So wrap handler was the code which it wraps the request. How many of you have actually struggled with handlers and or have worked with handlers, Mux handlers, basically? Handler function, and there are three things actually. There's a handler function, there's a handle, and no one, and handler. Yeah, there are three. Yeah, no one. Okay. So this is kind of like tricky because Go has inbuilt types, you could say. These would be types, yeah. So handler function is a type of a function. So it has a signature which says, hey, it should take a response writer, it should take a request, and it should also take a next next HTTP handler function. So using this, using Negroni, I just mapped it, added it to the handlers, and did it. So that was my adventures with writing a native Golang, and a server-side Golang code. Thing was, I started venturing or started playing around with FaaS. So function as a service. I was playing around with AWS basically. So I use this library called serverless.
There's a library called serverless.
Serverless.js actually. Okay, so think of serverless.js as just your getting started thing. Just use that to set up your project, or you don't really have to even do serverless.js to get started. So right now, FaaS is pretty much hot these days. People want to get into it or want to talk about FaaS all the way. One reason is that hey, it saves costs, server costs. You're not really managing multiple servers. All you're doing is hey, you're deploying your already unsticky. So we don't have the concept of sticky sessions anymore. So almost all our APIs can be done on any servers. We really depend on the database as a glue layer, as a layer which has all the information. So serverless basically steps in and says that hey, how about you don't manage your server as well? You just use functions. You just write a handler, and that handler alone will do all the heavy lifting for you. So that's the idea with serverless. Serverless JS was one library which helps you in getting started with across multiple different cloud providers. So it basically gives you the it sets you up a sample server implementation. So I won't be showing code which is big or which is like anything out of the ordinary or rather bigger than the hello world. So pretty much this is what the handler looks like. So I'm running it locally using AWS SAM. I think it has started up. Oh yeah, before that, I wanted to talk about this. So it's, when you get started with serverless, it gives you the serverless.yaml. You're basically defining all the functions which should be serving. So I have the hello handler, which is inside. So bin basically contains all my compiled binaries. So I have two main main.goals. One is hello, and the other is inside world. They don't do much except saying, "Hey, I'm ready," and this is it. Just returns a string back. It does not do much. So porting a lot of the servers right now on serverless is not a big deal. It's not that great a complexity. Okay, yeah, and it's running. And really, okay, I have internal server errors. Give me a second. So yeah, I'm using npm to start up serverless, but you don't really need npm. It's basically just doing this devrun.sh. So return is just file. So it does three things. It builds my Go code. It exports my serverless.yaml into template.yaml. So template.yaml is what AWS uses internally. So serverless is cloud agnostic. Serverless.yaml. You can use the same YAML for both Google Cloud for AWS Cloud Functions, AWS Lambda, and Azure's functions. Whereas template.yaml is specific to AWS. This is how you define a service. So it's not pretty readable or really hand codable. But there is an example actually. So yeah, running it locally is a pain. Sometimes. So the way this works is it's actually pulling a Docker image from AWS to run it locally. It's using the Lambda's image, Go image. Connect it to my local Docker. Just has to still load up. So I like this approach as well. So this approach was taken by Wagner. So he has instead of so I've used Docker images from AWS to run it locally. The other approach was to run it via Golang functions. I think I have the code locally. I'll just run it locally. So it kind of uses a FLs logic, but you have so AWS has written its own Gorilla implementation. It's like a wrapper over Gorilla, which emulates the Lambda functions locally. Slow. Okay, I'll let that complete. Any questions in the meanwhile? Okay, one other thing about AWS was it builds at 100 milliseconds intervals. So this Go code actually takes up like tens of milliseconds. It's not even that huge. So basically, you get build a lot more than what you're using. But then the thing is, your server utilization is much lower because you're not running it all 24/7. You're just running it how much ever request you get. So scaling on serverless becomes easier. So yeah, hey, my hello program actually ran finally. So this shows that it's running locally, but it's actually running inside a Docker container, which is AWS's Lambda container, and that's the one which is serving it. So I was listening to this podcast the other day. They were mentioning a lot of uptake on the serverless side. So as a developer, it still does not make sense for me to write serverless code because I can manage my own servers. I feel it's fine for me. But a lot of other industries like media, you have other industries which generally do not employ a lot of developers. They have only a few in their team which manage a few servers. And they are mainly focused on writing more features rather than managing their servers. So that's not the intention. So that's where serverless basically shines. Those are the industries. Yeah, I think I got the code now. So it uses API proxy Gorilla Mux, like I said. It also uses Mux. So if you're running it locally, so the approach I took was much longer. It takes, you can see that loading time is longer. Whereas with this, you're starting up a server locally itself instead of going through a building and then pushing it onto a Docker image. So if your argument is hey run it locally, it runs it locally. Run.go. So yeah, I don't expect that to complete. I think I'll stop with this. If you have any questions, I think now would be a good time. I know I covered a lot of. It was unfocused. I did not cover a lot of stuff in a structured manner, but I just really prepared it during Mohan's talk. So sorry, I didn't listen to your talk as well.
That is the same code.
Um,
Utilizing the AWS.
so this is what it does actually. So this one sets up the server such that hey, here if you pass in the argument as local, it starts up a server on 3000. Else it uses the lambda start. Since you don't really have a lambda server running locally, the other code will not run. Only the local code will run.
Also, what about the API interface? Like, what framework or something you use? Is it Swagger or something else? API document.
Oh yeah, that was Swagger documentation actually.
Swagger.
Yeah. Um,
Have you changed any CSS or something?
sorry.
Have you changed style things or different?
No, I use pretty much Swagger.
But the style is something different.
Yeah, probably it's the later version. I'll just check the version which I'm using.
Then you use style like.
Yeah, I know. Even I was surprised. I had used the earlier version. It does not really look that good. I'm actually glad they changed the UI.
Also, what about the framework you are using? Is it a plain Gorilla or something else?
Just Gorilla, Gorilla Mux, and Negroni as the middleware. JWT for the auth tokens.
That's like very business with the Lambda infrastructure. Like, how that works in the local.
Initially getting started with Lambda, most of the things, most of the times I was just deploying it on Lambda and testing it there, like using the invoke local. Serverless JS provides, it sets you up with
But the routing kind of stuff, like, are you using special?
no, just AWS Cloud Functions. Oh, sorry, AWS Lambda has this routing. I forgot the name. I just can't recall the name.
API gateway.
Let me just check that.
API gateway.
Yeah, API gateway. Sorry.
No, my question is about the local part. Like for the local setup, do you use any other?
I took two approaches. One was running Lambda Docker image locally. So I have entire Lambda running locally on my machine. So that does the routing for me. The other approach was using a Gorilla Mux approach, where so this HTTP does not come from Gorilla. Actually, it does. Yeah, sorry, it does. So no, it comes from so setup router, right? So this Mux comes from Gorilla Mux, like plain Gorilla, not AWS Gorilla.